Hello and welcome everyone. This is Manish Sharma from Skillable India, and in this particular session we are going to discuss the very important topic, which is the coordinate tolerances. Okay, when the GD previously the coordinate tolerances we use into our engineering drawing when there is no existence of the GD&T, but the problem is coordinate tolerance system has lot of drawbacks. Okay, so in this particular session I'm going to discuss over what are the advantages of GD&T over the coordinate tolerances and why we have removed this tolerance system from our engineering drawings. Okay, in coordinate tolerance, first of all we will know the definition. Okay, so coordinate tolerancing system is a dimensioning system which a part feature located or defined by means of rectangular dimension with plus minus dimensions. Okay, tolerances, plus minus tolerances. So whenever we are talking about the plus minus tolerances, like these tolerances we are talking about, so this type of tolerances when we provide, so these are called the coordinate tolerances. Okay, this is called the coordinate tolerance system or plus minus tolerance system. Okay, with coordinate tolerance tolerancing, dimensioning the part are given, but the drawing does not indicate how the part is to be set up for measurement. Okay, so this is the very important thing that is a drawback into the coordinate tolerancing. Okay, that it is not showing that how the part or it is not indicated. Actually, the datums are not finalized in that which datum we have to use, primary, secondary or tertiary datum. Okay, so these datums are not being defined in the engineering drawing. That's why in the drawing and the manufacturer, there is a lot of confusion between that. And in that confusion, a lot of parts get rejected. Okay, so in this particularly coordinate tolerance system, there are a lot of drawbacks. And in this, I'm going to discuss. Okay. So with the help of this example, you can see this method is simply this coordinate tolerance is simply incomplete method. Okay, and it does not precisely communicate the part requirement. It had a lot of drawbacks that there were. I will be telling you three major drawbacks of this coordinate tolerancing system. First one, where in this particularly in coordinate tolerances, we cannot precisely communicate the part intent or the requirement onto the engineering drawing. Okay, I have already told you that we cannot mention that we in the coordinate tolerance system we do not mention datums. Okay, so datums are not there, and datums are not there. Geometric characteristic is not there. Geometric characteristics we do not define onto the engineering drawing. Okay, so these are some of the drawbacks which are very important, which have to be overcome, and that is fulfilled by the geometric dimensioning and tolerancing, which is GD&T. Okay, so in this particular coordinate tolerance system have three major drawbacks. Okay, are listed below. So the first drawback is the drawing does not indicate how the part is to be set up or for measurement. Okay, so the first drawback is that it does not indicate the datums that which has to be used, primary datum for the inspection purpose or for the checking purpose. Okay, for the multiple quality assurances. So it does not indicate that the part how to how to be set up the part for measurement. Second drawback is square or rectangular shape tolerance zone. Okay, so in this the second drawback is it is square and rectangular shape the tolerance zone. Third one is ambiguous instruction for inspection. Okay, so one by one we will be understanding all three drawbacks. Okay, so the first one is drawing does not have the proper indication for measurement. Okay, so the location of these holes could be measured in multiple ways because of it is not specified onto the drawing. Okay, so in this you can see that the dimensions are only provided in the form of plus and minus tolerances. Okay, so here the position of this hole, if I want to find the position of this hole, given is only in the form of plus minus, let's say here 0.2. okay, tolerance in both x and y direction. So 0.2 tolerance is over here, 0.2 tolerance is over here. So from these two faces, okay, so from these two faces, if we are talking about these two faces, okay, so we can find out the center of this hole. Okay, so in this direction it is 25, and in this direction it is in the vertical direction it is 37.5. Okay, so with this this is the first drawback. In the second one, it is square or rectangular tolerance zone. Okay, so using the coordinate dimension, the shape of the tolerance zone for the position of the center of each hole is a square shape. Okay, so let's say we are taking an example for this position. Okay, so if I am taking this hole and I am using this as a true center, so what we are going to get is over here is true center. Okay, so this is we are going to use as a true center, this whole center. Now we have tolerances of 0.2 plus minus 0.2. So this 0.2 plus minus. So total we have 0.4 over here and 0.4 over here. Okay, now what the tolerance on both the side, by which we end up the square shape tolerance. Okay, because we have plus minus tolerance means this is we are having 0.4 and this is 0.4, so that we are having only the square shape tolerance zone. Okay, the shape is called the shape. This shape, square shape, is known as the tolerance zone. Since the shape is square, so we call it up as a square tolerance zone. Okay, if you see from the true center, if the hole is 0.25 in horizontal direction in this direction and 0.25 in the vertical direction. Okay, so but when the tolerance goes towards the diagonal, when the this moves towards the diagonal, when this moves towards the diagonal, it is more, and it is like in this case you can see this in this distance, diagonal distance is more than this 0.4. It is 0.57. Okay, so when we have more tolerance in diagonal direction, why not we have same amount of tolerance throughout the and this was the problem. Okay, why this diagonal tolerance we cannot use in the whole circle form. Okay, why we are lacking? If I am creating one circle over here like this, so this tolerance zone, this extra part, we are missing into this coordinate tolerance system. Okay, so this is one of the biggest problem what we are facing into this coordinate tolerance system, this square and rectangular shape tolerance zone. Now the third one is ambiguous instruction for inspection example. Okay, so in this particular example, in this drawing, it is not clear that how I have to check the center. In this, there are no datums. So we cannot find out that what datums we have to use first, second, and tertiary. Primary, secondary, and tertiary datums are not mentioned. So how I am going to check this part is not mentioned. Okay, here we have two probabilities. Okay, so the probability number 1 and probability number 2. A person who is checking the part face on the vertical direction, okay, horizontal direction, this face he can put onto the horizontal direction. So the distance between this hole and this point will be different. And if we check this in the vertical direction, if we put, okay, so this distance will be changed. Okay, so the vertical surface like this, and then just have a one contact point in this particular case. You can see this one contact point over here, okay, and the one contact point over here. We can also check this same part when this will be straight. Okay, this part will be shift. This surface will lie on this surface, and here is a gap. Okay, so the distance will change. Okay, so these type of datums, okay, datum A, datum B, datum C is not mentioned in this particular that which surface should be horizontal, which surface should be vertical, and to be aligned with the mating surface, okay, or to the surface plate, okay, whether it's a granite or, okay. So this is very, very important to check that with the help of example, we have understood that these are some of the problems which we face into the coordinate tolerance system. Face problem in measurement. Okay. Now we move forward. So these are some of the example. Okay. So this is the difference between the coordinate tolerance system and GD&T. Okay. So in this, you can see in this example, we have defined the plus minus tolerances, 15 plus minus 0.05. Okay. And these dimensions we have provided in the plus minus tolerance. But in this case, you can see, so if there you have it in this drawing, the center of these two holes, okay, center of these two holes are given with the dimensions. Okay, we can also use, let's say if I am giving this dimension with the given to the positional tolerance. Okay, if we need to find out the position tolerance of this hole, let's say this hole. Okay, so this type of dimension are more accurate. Okay, so in this you can see these type of dimensions are more accurate, and we have defined the datums in this to check. Okay, so in this also we have defined the datums. So this is a precisely, in this example, it is precisely communicate their part requirement better than what we get into the coordinate tolerance system. Okay, so here first, so these are the shortcomings we have getting into this example. Okay, now similarly, if in that case, if we use the square tolerance zone, so in this square tolerance zone, we get less amount of tolerance. Okay, coordinate tolerance system, which overcome by the circular tolerance zone. Okay, so in this case, we are getting this black area. You can see this black area, we are getting 57% more tolerance zone, in GD&T. Okay, so this is the major drawback what we are having in the coordinate tolerance system. True center, you go in any direction, you will get the same radius. Okay, whether you are moving in any direction, in this direction you will get the same radius, in this direction you will get the same radius, in all the direction, whichever direction you move, you will get the same radius, because of which we have the advantage apart from the that converting a square into a circle. So we have converted this square tolerance zone into a circular tolerance zone. So we have more area, and we get 57% more tolerance than we get in the coordinate tolerance system. Okay, so in this ambiguous instruction for the inspection, when we get the coordinate tolerancing system, so we may end up get different results. Okay, so in this we get different results after checking the part. For the after the inspection, we get different results. But whereas if we use the GD&T, okay, so this is the example of GD&T. If we use for the inspection, so it is very clearly shown that which datum, whether datum A, B or C, we have to use as primary datum, secondary datum and tertiary datum. So so the checking methodology is very clear for the inspector, and we get the accurate results with the help of GD&T. Okay. Now, as this is shown in this example, you can see this is also the example of coordinate tolerancing system. Okay, where you find all the dimensions with plus minus tolerances. Okay, when you have a drawing like this, whenever you have a drawing like this, you maybe end up part produced like this. Okay, so you can check any of the dimensions, which is the dimensions will be within the limit, within the tolerance, but within the limit of size, but the shape is not okay. Okay, so in this you can see that any dimension, all the dimensions are within the limit of size and all the tolerances are within the tolerance, but the shape is not okay. Okay, so this is the very frequent problem with the coordinate tolerancing system. Now, this is the another method by giving the instructions onto the drawing. Okay, so we have in the form of ambiguous instruction giving on drawings, which leads to misinterpretation. Okay, so this is not a functionally fit part. In the previous part, it is not functionally fit. Okay, in this alternate method, we can follow is to have the detailed literature. Okay, so the detailed literature like this it is given. But this alternate method have disadvantages also. Okay, what disadvantages is? What is one? It is a language dependent. Okay, so this type of method is language dependent. Another type of it is misinterpretation is very frequent. It consumes more space. Okay, so this type of consumes more space onto the drawing. Okay, so more time to make such type of drawings. So we wanted some better system, and that system called we have used as a GD&T. Okay, so geometric dimensioning and tolerancing, where in this you can see where all the symbols are used to get the precise communication with the part requirement or intent. Okay, so all the precisely communicated requirement. So in this drawing you can see that each hole or each slot is defined particularly with the dimensional tolerances. So it not only controls the size but also controls the shape of the part. So this is very, very important that all the dimensions in this, all the datums are mentioned, whether we have to, if for the inspection purpose or the quality insurance, if we want to identify the each and every dimensions onto the part, if you want to inspect it. Okay, so we have to be defined each and every datum. So what's the primary datum, secondary datum and tertiary datum. In the coming sessions, I'm going to tell you about datums in very detailed manner, that how the 6 degrees of freedoms we use. Okay, so 3 are rotational, 3 are translational. Okay, so all those things about datums, feature of size, in the coming sessions we are going to discuss. So this is all about this session of coordinate tolerance system. So it has a lot of drawbacks. That's why we have that's why we use the geometric dimensioning and tolerancing. Thank you everyone.